Hello, welcome back to Quantitative Gems. My name is Arden Thomas. I'm the Cincom Smalltalk product manager. Quantitative Gems is where we show you how to do numerical analysis using Cincom Smalltalk. Any questions, comments, suggestions, please send them to myself, Arden Thomas, at athomas@cincom.com. So today we're going to be talking about the relationship between numbers using something known as the Pearson Correlation Coefficient. And the Pearson Correlation Coefficient is a statistical measure from -1 to +1 of the relationship between two linear variables. So we're going to use two number arrays in Cincom Smalltalk. So what kind of things can you do with that? You can test a hypothesis, create a predictive model, find outliers in your data, or say if you take measurements with two different instruments, you can see how well they're correlated to see if they're both reliable. So other kinds of things you can do with it. You can, for example, you can find a correlation between children's height versus their age, or the temperature in the summer versus ice cream sales. You get the idea. It tells you how well two arrays are correlated. So what we're going to do, we're going to use, since we have data from some of our past quantitative gems of stocks, we're going to look at, see if a couple pairs of stocks are, or how they're correlated. Are they positively? Are they negatively correlated? And how strong? So right here is the formula for the Pearson Correlation Coefficient. So, for example, n times the sum of xy. And here is how I wrote it in Cincom Smalltalk. For the two data series I make sure that we're using apples to apples and have the common dates for each. And I get the x sum, y sum, x times y sum, etc. Basically following this formula. And if you see the Pearson Correlation Coefficient, this essentially correlates exactly to what I'm showing right here. I round it to the 100th and return it. So let's see that in action. I've got a couple series, one for the stock JP Morgan, one for the stock IBM. Now first let's test this. If I have the same series, the correlation should be 1. So let's print that. And in fact it is 1.0. If I negate the same series, we should have a Pearson Correlation Coefficient of -1. And lastly, even if I scale it, so I'm taking the same stock, multiplying it by 50, and comparing it to itself, and it knows the correlation is still exactly the same. But we're going to correlate JP Morgan stock prices with IBM stock prices, and we can see they are negatively correlated, which essentially means when one goes up, the other tends to go down, and it is 64% negatively correlated. By the way, the website I got this formula right here is right here, if you want to find that, and you can find lots of information on the web about the Pearson Correlation Coefficient. So to recap, the Pearson Correlation Coefficient gives us the relationship between arrays of numbers. We can use it for a number of things like I described right here. Here is the formula, which you can find at this website right here. And here it is in Cincom Smalltalk, which uses examples we've built and shared in the past to determine the correlation coefficient. Any questions, please send them to athomas@cincom.com. Until next time, have a great time with Cincom Smalltalk. one last thing, if you want to replicate this, here are the prerequisites that you need. And if you have any questions, give me a shout. Thank you.